Hello everyone, I'm Preeti and I'll be presenting our work on improving code comprehension through scaffolded self-explanation. In the current scenario of CS education, there is an overemphasis on code writing as compared to code reading, due to which students might miss out on developing deeper understanding of programming concepts, strategies, and techniques. Researchers argue that students should first master code comprehension before writing program. Code comprehension is the process of understanding code example through which an individual constructs mental representation of the program. In our study, we compared two different code comprehension strategies. First is reading, where students read worked out code examples annotated and developed by experts specifically for code comprehension. The second strategy is tutoring through our intelligent tutoring system, which looks something as shown in the figure. In our tutoring system, the tutor first asks the student to self-explain a worked out code example in as much detail as possible, and their self-explanation is automatically assessed based on semantic similarity with reference to expert's explanation, and scaffoldings or hints is provided for the incomplete or incorrect part of the student's response. Only once the student's response is complete and correct, the student move on to the next task. So our main research question is to the comparison of effectiveness of reading versus scaffolded self-explanation for code comprehension and learning. We also investigate the effectiveness of two techniques for students with varying prior knowledge. For this, we conducted a randomized control trial experiment where students were randomly assigned to control group where the main task was to read annotated code example, and experimental group where students interacted with deep code tutor. Both the groups were exposed to equivalent content, and we used normalized learning gain with pre-post test comparison as our main metric for evaluation. We mainly focused on introductory programming concepts such as loop, arrays, classes, and so on. 89 of the total 90 participants completed all the tasks. We conducted this experiment towards the end of fall 2022, and 47 of the participants were randomly assigned to control and the rest in the experimental group. We found that students with a different major participated in our experiment. Our results indicated that the learning in experimental group was slightly higher as compared to that of control group, but the results were not statistically significant. We also found the effect size to be a small value of 0.2 in favor of scaffolded self-explanation using deep code tutor. Our results also indicated that students with low prior knowledge demonstrated significantly higher learning gain than students with high prior knowledge in the experimental group, but no such differences were observed in similar grouping of student in control condition. In our future work, we will further experiment with code comprehension with more challenging code examples. Thank you.